this session, we're going to look at doing two-factor authentication with Google Authenticator. Now, this isn't necessarily a specific feature of PowerBuilder 2019, but some of the features that have been added in 2017 and 2019 do make this possible. So first thing we're going to do is have the legal disclaimer. Here's the agenda. I'm going to talk about myself for a little bit, and then I'm going to just give a high-level overview of how two-factor authentication works, what Google Authenticator is, and how that helps you do two-factor authentication. Then we're going to look under the covers and see at a little bit lower level how we do this in PowerBuilder. And then for the people who are interested in actually implementing this, we're going to go deep in the weeds and actually go through the code that makes it happen. And then we'll have a question and answer session. So a little bit about me. I've been using PowerBuilder since version 1. Shortly after I started using it, I decided that this was something I could do as an independent contractor, and so I did that for about 15 years. And then at that point decided I wanted to go back and work full-time for a company, and so I went to work for a company called Integrated Data Services, originally doing PowerBuilder development for them. I've moved on to other things there. In addition to PowerBuilder, some of the languages I'm also highly fluent in are Oracle PL/SQL, Java, C#, and as well as C++. And then I'm involved in quite a number of open source projects. I've listed a few there I thought were more of interest to the PowerBuilder community, including the open source PowerBuilder Foundation classes. This is the foundation classes that PowerSoft originally wrote, and then Sybase, beginning with version 10 of PowerBuilder, open sourced them. And I've been one of the people that has helped contribute to that on an ongoing basis. A little bit about the company I work for, and let's talk about what two-factor authentication is. So normally, in most applications, what you do is somebody logs into an application or even logging into a website, they have a username and a password. Now the problem with that is that's two pieces of information that could be easily obtained by a third party and then used to access the person's account and do nefarious things. So the idea is that with two-factor authentication is you want to have two different ways of identifying the user, so that a third-party actor who wanted to do harm might be able to get one of the two factors, but the chances they could get both are remote. So you could still use a password. This would be something you know, but then you have then the second factor is something you have. So in the specific case, you could let's say you could have Google Authenticator on your phone. So in order for somebody to access your account, they would need to have your password and they would need to have your phone, because the Google Authenticator is going to generate a PIN code that you're going to enter into the application. And if the person can't enter in both the password and the PIN code, then they can't get into your account. So you would have to allow somebody to get your password and your phone, and they would need to be able to unlock your phone in order to actually access your account. There's another kind of another factor that can be used is something you are, and that would be if you wanted to use a fingerprint reader or a retinal scanner. That's another way you could do two-factor authentication. Okay, so this is a high-level overview of how this works with Google Authenticator. So what you're going to do is when you first go to use the application, I'm showing more than what the application would actually show. What the application would show when it wants to set up with two-factor authentication is just this QR code. I'm showing how you generate that. You have the application name, you have the user ID, and you have a secret key. Now the secret key is supposed to be a secret. I'm just allowing you to enter it so you can experiment with this. But you would generate a secret key for that user. And then you take those 3 pieces of information and you generate a QR code for them. And then what happens is you go into Google Authenticator, Google Authenticator scans that QR code, and it registers that application with that username and password into the Google Authenticator app. And then it starts generating what it's called one-time time-based passwords, or PIN values. So here's an example of what that looks like. Now what it does is it generates one of those every 30 seconds. So you go to log into the app. What you're going to do is you're going to enter your username and password, and then this 6-digit PIN code, and within the 30-second window that that code is available for. And what the application is going to do then is it's going to take, the application knows that your username and knows its own name, and obviously, but it knows your username and it knows the secret key that it gave you, and it's going to go ahead and generate that same one-time password, or the PIN value, and then it's going to compare the two. And so if the PIN value that it generates matches the PIN value that the user provided from Google Authenticator, then the application knows that the person actually has the Google Authenticator with the application registered in it. And this is basically everything I just talked about. There's some links here if you want to get some more information on how a time-based one-time password is generated. Okay, so that's the high-level overview. Now we're going to see how we implement this from PowerBuilder. So first of all, we have to generate a QR code. So we take the secret code for the user, and just to make this simple, I just took 1, 2, 3, 4, 5, 6, 7, 8, 9, 0 twice. You I almost said base 64 encode. You base 32 encode the value. Base 32 is a little bit more of an esoteric encoding format than base 64. What was introduced in PowerBuilder 2017 was base 64 encoding. Unfortunately, that PowerBuilder hasn't a native base 32 coding method yet. And so when we go deep in the weeds, we'll see how I created a base 32 encoding routine in PowerBuilder. So this is what you get when you base 32 encode this key value. You get this hexadecimal string. Well, it's not quite hexadecimal, but this is a base 32 encoded string. Okay. Then we're going to create an identifier by concatenating the name of the application, a colon, and then the user ID. So I called in this case I called the application Google Authenticator Demo, a colon, and then my email address is what I'm using for my user ID. Then I insert them into the following string. Okay, so you get the TOTP / the identifier is this piece right here, the Google Authenticator Demo, colon, email address, and then behind that add a question mark, secret equals, and then the base 32 encoded key value. So this is what we end up with once you plug all those in. Okay, and then we take and URL encode that string, that whole string with the OTP auth, all of this. And one of the features that was added to PowerBuilder 2017 was the ability to URL encode, so we're going to use that feature. And then we need to generate a QR code for the string. And I use a Google library to do that. When we get into the deep in the weeds section, you'll see how that works. Okay, so now we need, that generates a QR code. Google Authenticator scans that, registers the application in itself, and it starts generating the one-time passwords. So the user enters their one-time password, and now we need to validate that, well, the PIN value, and we need to validate the PIN. So what we're going to do is we're going to take that same key, and we're going to use the same algorithm that Google Authenticator uses to generate the same PIN value, or generate a PIN value, and then compare them to make sure they're the same. Now, the one thing that may be an issue here is that because the PIN is time-based, if the computer time, the time that on the computer that the PowerBuilder app is running on is off by a few seconds, let's say it's off by 30 seconds, you're never going to get a match, or it'd be a lot harder to get a match because this code is regenerated every 30 seconds. What you might want to do in that case is generate a PIN, figure out what the interval is, and generate a PIN value for that interval, but then also generate PIN values for the interval before it, and allow and for the one after it. And so you have 3 different PIN values. Compare the PIN value the user entered with all 3 PIN values, and then you somewhat compensate for a minor difference in the computer time. If the computer time is majorly different, you're never going to get a match, and that's something you'll have to, that's maybe a training issue for the users to make sure that their computer times are set accurately using an NTP service of some kind. Okay, so we want to generate the same PIN value that Google Authenticator is going to generate. The way we do that is we get the current time in UTC, or it's also called GMT, Greenwich Meridian Time, or Universal Time. And we take that time, the current time in GMT, and we convert it into what's called a Unix epoch format, where that's the number of seconds since midnight, January 1st, 1970. So let's say today was May 1st, 2019, and it's 8 a.m. The Unix epoch for that, assuming the 8 a.m. is GMT, is 1,556,697,600. You divide that by 30, and that gets you the interval. So this is how you get these 30-second windows. So, and we truncate to the a full integer. Well, not a full. We drop off the fraction here. So we get 51,889,920. That's the interval. Okay, we convert that into a 4-byte array. But we need it in what's called big Indian format, and the Windows API function that is available to do a long to 4-byte array provides it in little Indian format. So we need to actually reverse that. Let me go back here. You can see what the value is: 0, then 199, then 23, and then 3. That's what this value is once you convert it into a 4-byte array. Okay, but like I said, we need it in a big Indian format, and that just means the bytes are reversed. So instead of 0 and 199, 23, 3, we want to have 3, 23, 199, and 0. And then we add 4 leading zeros to the beginning of that. Okay. We then HMAC encode the byte array using SHA-1 and the secret key that we have for the user. So this is where that user specific information starts to come in. And now once again, One of the features that was added in PowerBuilder 2017 was the ability to HMAC encode data. And so we're going to use that feature to HMAC encode this byte array. So this is what you get after you HMAC encode the byte array. We take the last byte, this 175 in this case, and we do a bitwise AND with F to strip off the highest bit. So now we get 15 rather than one. I'm not sure why there's a typo there. That should have been 175 and F equal 15. Okay, that determines the offset that we're going to go into that byte array and copy 4 bytes out of. So going back here, if this says 15, so we count in 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. If I did it correctly, we should be getting these 4 bytes: 53, 199, 117, and 230. So let's see if that's what we end up with here. Oh, I did it wrong. Let's go back and look at that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I think maybe the pointer starts with 0. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That's what it is. Sorry about that. So it's a 0-based index. And so we start with 199, 117, 230, and 20. We take the first byte of that and we do a bitwise AND with 7F. And that gives us 71. And then we multiply each of the bytes. So we have the 71 that we just calculated, and we multiply it by 2 to the 24th. We take the second bit, multiply it by 2 to the 16th. The third bit, multiply it by 2 to the 8th. And to the fourth bit, we just take as it is. What we're doing is we're left shifting the values, essentially. If you had them in binary format, that's what you would be doing. Is you would be bit shifting them, and then we add these together. So we take the 1,191,182,336, the 7 million value, 58,000 value, and 20, and we get this 1,198,000. Sorry, million 908,948. Okay, now we're going to take the mod, take the mod of it, and this is the value we get left. So the mod is when you divide this by this, what remains after you do that division. And so we get this value, this area, this section right here, 908,948. That's what the mod will be. So that's the pin value, and if it's less than 6 characters, we pad it with zeros to make sure that it's 6 characters. In this case, it was 6 characters already, so the pin value we got was 908,948. So that kind of explains the process. Now we're going to look how I said earlier we're going to look to see how we do it in PowerBuilder, but that's actually the next section where we go deep in the weeds here. Okay, so this is how we generate the QR code. So I'm going to create a coder object and an HTTP client object. One of the reasons I'm going to create the coder object is because not because of the base 32 encoding, but because of the URL encoding that I'll be doing here a little bit later. I've got a separate function here that does base 32 encoding. I actually have a user object that does it. So we're going to base 32 and encode the key. We take the identifier and the secret and put it all together into that string that we need the URL encode. So here we are. I'll convert this to a blob first because the URL encoding function takes blobs. So I'm going to take that URL, put it into a UTF-8 encoded blob, and then a URL encoded. This is where I'm using that PowerBuilder 2017 feature. Now here's a chart API that Google has available that creates QR codes. All I need to do is pass in the value that I want to convert into a QR code, and then indicate what size I want it to be. And then this is where I'm using the HTTP client just to do a GET request, and I pass in this chart URL, and I get a response back. And what I actually want, though, is I do a GET response body to get the blob that contains the QR code. And what I do then is I just add that to a picture object. Assign that to a picture object, and the QR code displays. Now this is the function where I'm doing base 32 encoding. So the reason it's called base 32 is I've got the 26 letters of the alphabet, and then 6 additional digits, starting actually with 2, 3, 4, 5, 6, 7. So that's our base. It's our 32 character base. What I do is I then take the length of the data, loop through it, get each character, get its ASCII value, then do a num to bin on it. And there's another function that I borrowed from the PowerBuilder Foundation classes that do the number to binary here. And then string together the binary values. So what you get is you basically convert that key that was passed in into its binary format. I get the length of the binary format, and the binary there's actually a specific length that the pin has to be, because what you're going to end up with, you should end up with, is about a 40 character binary value. And what you're going to do then is divide it into 5 chunks, and then that's what's going on there. So each it started out with a bunch of 8-byte values. You pen the 8-byte values together, then you divide them into 5-byte pieces, and then we're going to convert those back into the base 32. Each of those pieces, each of those 5-byte pieces, is then going to be converted back into a 32, one of the characters in that 32-bit character set. And then finally, there's a padding that goes on to the end of it, depending on let me go back here for a second. I calculate the pad, yeah, by taking 5 and separating out this mod value. That tells me how many characters I have to actually pad onto the end. So a little complex, but it works. You can just go ahead and use it. Here's the num to bin, and I just borrowed this from PFC, and also bin the num, which I borrowed from PFC. So that's how you base 32 encode the secret key to embed in the QR code. Okay, now we want to generate the pin value, because we want to see what the pin value should be and compare it to what the user entered. So I have a function I created called get Unix epoch that gets me the current time in GMT in Unix epoch format, and we'll see that in a second. But I take that number of seconds, I divide by 30 because that's my interval length, and then I have a function called generate pin that actually generates the pin based on the secret key and the current interval. And so these are the local external function declarations for some API calls in the Windows API that I'll be using to get the Unix epoch format. So I need to get the time zone information because I need to know what time zone the computer's in, and then I'm going to then I use this function that converts a specific local time to a system time, which will be the GMT format, or GMT time. So this is where I get the time zone information, convert it to a PowerBuilder system time. I use the specific local time to system time function to convert that local time to GMT. I convert that that UTC system time back to a PowerBuilder date time. I then do a days after from January 1st, 1970. That gives me a number of elapsed days. I also do a seconds after from midnight, and then the epoch would be the number of days since January 1st, 1970, times 24 times 60 times 60, so it's converted into seconds, plus the seconds from the seconds after, and that gives me the Unix epoch time. Okay. Now what I'm going to do, that's how I got the Unix epoch time divided by 30. I have my interval. I have my interval and my secret key. Now what I'm going to do is generate the pin value. So what I do is I have to take the counter is the interval, and I'm going to convert that to a byte array, and then convert that byte array to a blob. And then I'm going to take the key value. That's because, and the reason I'm converting it into a blob is because I'm going to do the HMAC on it. Remember, I have to do an HMAC using SHA-1. This is where I'm using that new crypto object from PowerBuilder 2017. So I take the key value, convert it to a blob, do the HMAC using SHA-1 on it. That gives me a blob with the encoded value, or the hashed value, I should say. I convert that back into a byte array. Now that I've got that byte array, I take the last byte from that and do a bitwise AND on it with 15, which is F. And that gives me my pointer, if you remember my walking through how this works. So then I do an offset into the my byte of my time value. Let me go back here. Oh no, not my time value. This gets the pointer that points back into itself, the hash bytes here of the key. So this gets me my 4 bytes. Here's where I'm doing the bitwise AND with 127, which is the 7F value. And then I'm actually doing the multiplication that does essentially the left shift in here as well. So I'm taking the first value, multiplying it by, after I do the bitwise AND on it, I'm multiplying it by 2 to the 24th. The second byte I multiply by 2 to the 16th, third byte by 2 to the 8th, and I just take the last byte by itself. And also, while I'm in here, I'm adding, once you notice, I'm taking the selected long value and adding on each of the calculated values. So I'm doing the add in this loop as well. So these all get added together. Now I do the mod with 1 million. That gives me my pin value. I check to see how long it is, and if it's less than 6 characters, I fill the front of it with zeros. So that's the PowerBuilder version of what I explained in the last section of how you generate the pin. Notice I had the copy long to bytes. This is the API call I'm using. So it takes in the 4 bytes and the long. So the bytes come back actually in this value. This is the long we're passing in and how long it is. But remember, I also said that it does it in little Indian format, and we need big Indian format. So what I'm doing here is after I take and convert the long to an array of bytes, I pad the data. And what I'm doing here, this is the result at the end. So I put 4 zeros on the front of it, and then I take this value here and I copy them in inverse order onto the end of that byte array. So what we get is 4 zeros and then these 4 bytes, but in the inverse order of what the API function gave us. This is bitwise and this also I borrowed from PFC. Okay, we're going to do some two-factor authentication now. So this is my little sample app for it. I run that. So I've named my app Google Authenticator Demo. There's my email address that I'm using for user ID. This is the secret key that's tied to my account. Obviously, you want to display this to the user. I've just got it there so you can put in different codes and test things out. So those three things are used to generate a QR code. There's the QR code we generated using the Google API. I'm going to bring over little utility, lets you see my iPad. So there's my iPad with Google Authenticator running on it. And I'm going to say begin setup, scan barcode, and it's going to try to find the barcode. I got to move this window out of the way. There we go. So it picked it up. So the code it's generated is 718258. Now we're going to generate that same code here on the client, and sure enough, we generated that same code. Let me bring so we're going to wait about 30 seconds here. That thing will start flashing to let us know that our 30-second, there it is, it's flashing red. That means we're approaching the end of our 30-second interval. That's the new code, 765586. Hit validate it right over here. That's Google Authenticator and PowerBuilder both independently generating that code, and then you can compare them, and if you get the same value, you know that this is the user because they've registered the account with the Google Authenticator. So that's two-factor authentication. Any questions?